The multi-temperature grinder, a grinder that grinds at hot, not, or cold temperatures, by Miss Anne Abraham. The necessity of a new grinder with temperature controls. Existing grinder motors are not powerful enough. Existing grinders do not have the temperature controls built in with the grinder appliance. The solution: a grinder with a powerful motor as necessitated by the need to make nougat or grind wheat. A grinder with temperature controls keeping the grinding mixture at either hot, cold, or at room temperature. A grinder with an option of grinding stones or steel whisk, or more attachments depending on the necessity. The multi-temperature grinder. This slide shows the top view and the side view, which will be explained in the next slides. The top view. In the top view figure, please note the inner vessel labeled 1. This is the vessel that holds the mixture to be ground. The central square labeled 2 is a cuboidal pillar that is rotated by a socket below connected to a strong motor. Just surrounding it is a grinding stone 4, which is turned as the cuboidal pillar 2 is turned by the strong motor. The surrounding squares labeled 3 are cuboidal pillars that are fixed to a removable base. The grinding stones labeled 4, which are cylindrical on the outside with a square cuboidal hole in the inside, are slotted onto cuboidal pillars 3. These surrounding stones are thus held stationary. When the central cuboidal pillar 2 rotates, the cylindrical grinding stone slotted on it turns. This rubs against the surrounding stationary cylindrical grinding stones. The mixture which gets in between these stones gets ground between the turning central cylindrical stone and the stationary surrounding cylindrical stones. There are built-in spatulas labeled 8, which direct the mixture toward the center of the vessel for grinding between the stones. The multi-temperature concept. The gap between vessels 1 and 5, which are connected, the gap between vessels 1 and 5, labeled 5A, is filled with a liquid for the double boiler concept. This liquid is heated by a heating element that wraps around the lower half of the vessel 5 on the outside. When the heating element is switched on by a switch, it gets hot, and the heat is conducted to the liquid in the gap 5A. The heated liquid rises up, and the liquid above it flows down and gets heated. Hence, the entire liquid in the gap 5A gets heated. This heat is conducted through a vessel 1 to the mixture inside, so the mixture gets heated while it is ground. This is the primary purpose of the application. It is used primarily to make chocolate. Similarly, if the temperature control is turned to the cold temperature, then only the cooling element gets cold around the upper half of the vessel labeled 5. The liquid in the gap labeled 5A is then cooled by conduction, it settles down, and the liquid below it is displaced so that it rises and is next to the cooling element. Hence, it gets cooled completely, and this cooling is conducted through the vessel 1 to the mixture which is being processed in the vessel, and hence the mixture is ground or processed at a cold temperature. This is primarily to make ice cream with a steel whisk. If the temperature control is not set to either hot or cold but is in the off position, then neither heating nor cooling happens and the mixture is processed at room temperature. This is primarily to make nougat or idli dosa batter or grind wheat, depending on the attachment blade used. This capitalizes on the exceptionally strong motor. In the side view, the black rectangles represent the cuboidal pillars. Rectangles around them represent the grinding stones slotted onto the cuboidal pillars with the same numbering as in the top view diagram. The side view of the spatulas is also seen in the diagram. The heating element at the lower half on the outside is labeled H, and the cooling element on the upper half is labeled C. The motor base unit has a central socket to turn the central cuboidal pillar and also a temperature control for heating or cooling and an on-off switch. Apart from the central cuboidal pillar labeled 2, the other elements within vessel 1 are removable, and once the grinding stones labeled 4 are removed, then the cuboidal pillars 3 and the spatula 8, which are fixed on a removable support structure, can also be removed from the vessel 1. This slide shows the side view of the removable support structure. The numbers mean the same as in the top view slide. This slide shows the side view of the removable support structure. The numbers mean the same as in the multi-temperature grinder top view slide. Applications of the multi-temperature grinder. Grinding of a mixture at a hot temperature, as in chocolate making. Grinding of a mixture at room temperature, as in nougat making. Grinding of a mixture at a cold temperature, as in ice cream making. This is the end of the current presentation. Thank you for listening. Let's build it. This was brought to you by Ms. Anne Abraham.